Have you ever wondered if you could step back in time, perhaps to correct past mistakes or relive cherished memories? A question that has intrigued humanity for centuries, captivating our imaginations and sparking countless debates. The idea of journeying through the corridors of time, altering history, or simply revisiting bygone eras is indeed enthralling. And while it may seem like the stuff of science fiction, the reality could be quite different. Well, the concept of time travel might not be as far-fetched as you think. Time travel, in essence, refers to the concept of moving between different points in time, just as we move through space. Now, that might seem like something straight out of a science fiction novel, but let's try to unravel this concept piece by piece. At the heart of time travel lies the concept of the space-time continuum, a four-dimensional framework that fuses the three dimensions of space with the one dimension of time. Imagine a sheet of paper. This flat surface represents space. Now, bend this sheet. The bending signifies the passing of time. This sheet, now a continuum, is the universe we live in. The concept of time travel is rooted in this space-time fabric. The idea is, if we can manipulate this fabric, we could, in theory, move back and forth in time. But how can we manipulate space-time? Here's where the role of speed and gravity comes in. According to Einstein's theory of relativity, the faster we move, the slower time passes. This is called time dilation. For example, if you were to travel at nearly the speed of light, time would slow down for you relative to someone who is stationary. You could return to find that while only a few years have passed for you, decades have passed for everyone else. Gravity similarly affects time. Strong gravitational forces can slow down time. This is why time moves slower near a massive object like a black hole than it does in outer space. These principles are fascinating, aren't they? They essentially suggest that if we could move fast enough or find a strong enough gravitational field, we might be able to travel into the future. As for traveling to the past, that's a bit more complicated. Theoretical physics suggests concepts like wormholes and quantum entanglement might allow for such a journey, but these ideas are still largely unproven and remain the stuff of science fiction. So, in theory, time travel could be possible. But what about the practical implications? While time travel makes for great science fiction, it also presents some perplexing paradoxes and problems. So, what are these snags that make the concept of time travel a bit of a mind bender, especially when we consider going back in time? Let's start with one of the most famous paradoxes, the grandfather paradox. Imagine, if you will, a time traveler journeying back in time and accidentally causing the demise of their own grandfather before the birth of their parent. This would mean the time traveler was never born, but if they were never born, how could they have traveled back in time? This creates a loop that's impossible to resolve, and it's just one of the many paradoxes that plague the concept of time travel. Then there's the issue of alternate timelines. If you could travel back in time and make a change, even a small one, it could create a ripple effect, altering the course of history. You might return to a present that's completely different from the one you left. It's a concept often explored in science fiction, but the implications are rather daunting in reality. And let's not forget the physical constraints. The energy and technology required for time travel, as per our current understanding of physics, is simply beyond our reach. These paradoxes highlight why time travel, especially to the past, remains a controversial concept. So, can you time travel to the past? The answer is complicated. We've taken a fascinating journey through the concept of time travel, navigating the winding roads of theoretical possibilities and paradoxes. It's a vast landscape, filled with mind-bending ideas that challenge our understanding of the universe. We've discovered that time travel, at least in theory, is not entirely out of reach. Yet, we've also bumped into pesky paradoxes that seem to muddy the waters, making the whole idea incredibly complex. The grandfather paradox, the bootstrap paradox, all these conundrums suggest that our understanding of time and space still has plenty of room to grow. Yet despite these challenges, our curiosity remains unquenched. The question of time travel keeps us on our toes, pushing us to explore the boundaries of what we think we know. While we may not be packing our bags for a journey to the past anytime soon, the exploration of time travel continues to captivate scientists and laymen alike. Keep questioning, keep wondering, and who knows what discoveries await us in the future or the past.